course, oddly enough, the new generation has no idea how satisfying it is to be able to do this to people on the phone, and they have no idea what I'm doing. Okay, let's work with a new data set. This one's pretty complicated, but that's going to be on purpose because it's actually going to be very similar to how the final project goes. So this is the weather data set, and I had a little bit of a problem when I tried to do a read.table. So in this case, I did a read.csv, and I told it the separator was a space. I'm pretty sure that relates to something funny I must have done when I created this made-up data and saved the file. Our goal is going to be, let's predict temperature. And in the next video, we'll do humidity. But temperature is going to be a little easier, so let's start with that. We have a whole bunch of variables, which makes this very similar to the final project. That's why we're doing it this way. Now, I'm going to start by looking at the histogram. Here's my temperatures. Why would I want to do that? Well, I might like to talk to the client about what kind of temperatures they can expect, which makes sense if our goal here is to try to predict the temperature. Well, on average, we should be between 44 and 45 with 95% confidence. And you could argue, if nothing else, at least I can predict what I expect the temperature to be, not knowing any other variables. So now let's look at the other variables and see if we can figure out how they can help us predict the temperature. And yes, I've already gone through all of the data because you wouldn't believe how many times I misspelled temperature or air pressure and had to redo this. And if we were in class, yes, I might actually make you sit there and watch me type this, but in a YouTube video, I'm not sure that'd go so well. So let's just jump to the code that has all the spelling errors fixed. So when I plot temperature versus air pressure, okay, all the air pressures seem to be going like this, and then there's this zero here, and I went through this the first time thinking, boy, I'm not sure how I feel about that zero. There's also a zero in the system, and wind speed looks good. There's a funny zero down there, and then altitude, this looks fine, and clouds, there was another funny zero, and snow melt had another funny zero, and at some point I said, hold on. It looks to me like there's always this funny zero. I wonder if there's an error in the data set. And looking back at the cloud data, all the data's in this range. That guy's got to be an error. So I decided to take him out. I want weather to only show me the rows where the clouds are greater than zero. Okay, so let's start over. Air pressure, now this looks much better. It's a very strange curve. I don't know how I'm going to map that. There's system and wind speed, altitude, clouds, snow melt, and then we hit ground level. Ground level apparently is in the 20 to 80 range with one negative value. I'm going to say that's an error, so let's take it out. And now look, ground level looks much better. And for each of these other variables, funding and pressure change, again looks weird. There's this huge high variable. Everybody else is so much less that they look like a straight line here because that guy is so huge. So let's take out the big pressure change value, which I didn't replot pressure change. Hang on. We gotta fix this. I should pause the video. Let's redo pressure change. Oh, that does look much better. Okay, so finally, and yes, animal behavior has this zero. I deleted it, which is why nothing's showing up here. And if I wasn't still mad at the last video, I would take it out just because it looks better that way. But I know this video is going to be long already. Let's not make it longer. Let's just do a fix. And so what did I do? I threw all those variables in. Notice that I just gave them all simple linear relationships. Okay. So then my next step was, let's start looking at the residuals based on each of the variables, and I get this problem. Why does this happen? Because somewhere there's an NA hidden, and because of that, my residuals are one less, because when it did the fit, it took out the row that had the NA. But when I look at all the air pressure values, that NA is not there. So NA.omit says, go through my data set, find the NA, and take out the row for me. So now, if I redo it, there is my residual against air pressure. I'm hoping to not see any pattern here. Do I see a pattern? Actually, kind of maybe a little bit, right? There seems to be a streak here, some bouncing, like a bounce there. I'm not so sure at this point how I'm going to model that. I told you I already went through this data set. I know the end of the answer. I'm just trying not to spoil the movie. So our goal is not necessarily to fix every residual plot as we go through. Our goal here is to find the one residual plot that looks the worst and how can we fix it. So air pressure has something maybe to fix. System, I don't know, I'm not seeing a whole lot there. Wind speed, maybe a log, we'll come back to that. Altitude, I don't know. Clouds. This one was the one I felt like was most obvious. See the smile there? That's a quadratic. So I remember to do a quadratic there. This one has these high outliers. I'm thinking a log might be appropriate here. And it might not. There's lots of ways you can get that kind of pattern. And then we come to funding. I'm seeing a cubic here. You see that little curve happening right here? So looks like there's 3 residuals that are definite. I have an idea of what to do. The others I'm not so sure. So I added in the cloud squared to give it the smile. I added in funding cubed to give it that swirl that we saw. And then a log of snowmelt. Let's throw that in, see how it looks. Okay, so now air pressure is looking good. Remember the pattern we saw before? I don't see that pattern anymore. Now, air pressure is not one of the variables that we fixed up here. So why is air pressure looking better? It's because of multicollinearity. Air pressure must have been highly collinear with one of these other variables that we fixed. And so that made its residual look good. I'd like to see these box plots all looking the same, but I'm not sure what to do here. Wind speed, still seeing some outliers, so maybe I'm going to try a log. Not sure if that's going to work. That's looking good, looking good. And here I'm still seeing some outliers, so I'm thinking, okay, maybe a log. And then I actually typed it in log, and then I went and looked, and oh, I did log snowmelt. So should I log the log? The mathematicians are saying, yay, do that. Well, no, that seems dumb, so I decided not to. You could actually argue for it, and since you're allowed to fish in this class, if you want to try logging a log, you're allowed to. But theoretically, that's going to be really hard to interpret. These other variables look good. Now, polar vortex, I spent a long time. Do you see the bow tie shape here? Could it be that there's an interaction? But going through all the others, I didn't see any real strong bow tie evidence, and so in the end I talked myself out of trying to make an interaction with polar vortex. Like I even know what a polar vortex is in the first place. So here's my new fit. I'm going to try log wind speed, and going through these variables, they're looking better. Now, this one's maybe a little better. I'd still like to see that fixed. There may not be a good fix for this one. And I still see some outliers here, so that may just be the way snowmelt is. It might be that snowmelt has a lot of data that's low on one end and high on the other. So, all right, I'm feeling good. I think my residuals are as good as I can get them. I played with trying to find an interaction for polar vortex. I even actually tried some interactions and they weren't significant. So now we're going to go look at our summary. And apparently I copied my fit right here. I don't know why. But looking at this, what should we take out? It looks like wind speed is pretty high and animal behavior is pretty high. So I decided to take out animal behavior. You could argue the other one if you had some reason to. Here I'm seeing I have log wind speed. That's highly significant. But wind speed itself is not. It makes sense that it should either be logged or not logged. To have both wind speed and log wind speed really doesn't make sense. So taking out wind speed is a good thing. It's going to make my model more reasonable. Now what should I do? It looks like air pressure is what I said. Oh yeah, 0.75. That's a good one. So now, next it says take out smog. Do I agree with that? Pressure change is 0.22. Where's smog? Oh, right here, 0.77. Yeah, we'll take out smog. Run it again. If I was doing this in front of class, I would just go back up to the fit statement I had before and change it here, but I want you to have the code so that you can walk through it the way I did, so this is why I'm overdoing everything. I'm betting pressure change is next. Yay, it was! And it looks like this is where I stopped taking stuff out. Okay, everything's still significant. Now there is one funny thing right here. If you notice, we have log snowmelt and snowmelt. And I just finished 10 seconds ago telling you you shouldn't have x and log x both in the model. So I'm going to argue that what we have is not theoretically the true model, but it's giving us good predictions. So I could decide to take one or the other out. Which one would I take out? 0.024 versus 0.032. So I guess I would probably take out the log snowmelt. But I want to have the log in there. And I actually decided to leave it in partly because I want to play with the idea of how do you talk about something where snowmelt and log snowmelts are in the model. So I left them in there. And then this command helped me to see all my coefficients listed out, but I didn't like the way that was listed. So then I tried this one, and that helped me to make this prediction equation here. So I copied these numbers, put them in next to each of their variable, and gave them values. And looking at this, which variables are going to be easy to explain? System, altitude, but not clouds. Clouds isn't going to be easy to explain because we have clouds and we have clouds squared. So clouds is going to be tricky. Snowmelt's going to be tricky because we have a log and a not log. Funding is also going to be tricky because it's cubic. So those three, I decided I want to do a picture. So let's start with the clouds picture. If I'm trying to draw the effect of clouds, I'm going to make clouds a sequence that goes from 100 to 300. Length of 1,000 doesn't really matter, that's just how many dots there are. And then I use my prediction equation. And it gives me nice, reasonable values because I went ahead and gave all the other values like altitude. Even though I don't really need altitude to be defined, I could have picked different altitude values and it would just shift this up or down. But there's a nice cloud picture. And we can do the same for snowmelt. Remember, snowmelt is the one that had x and log x. So I'm not going to explain it with a nice sentence. I'm going to describe this picture. And if you remember the graph that we showed clear up here at the beginning, that does seem a good fit for what the data appears to be doing. So there's my picture of snowmelt. I'm not going to use numbers. I'm just going to describe what's happening here. And the last one was funding, which was the cubic. And there is my cubic. Now the one that got logged that didn't have, not snow hat, I'm talking wind speed, because wind speed didn't have non-wind speed in there. The coefficient was a 21.43. So if I'm going to describe the effective wind speed, I'm going to take that 21.43 times the log of 1.05, because I'm going to say x increases by 5%. Memorize that number, we'll see it again. All right, let's open up Word and talk about my document. First thing, I'm going to describe temperatures. Here's the kinds of temperatures. This is what we're trying to predict. The average is right between 44 and 45.4. And now I can do my prediction equation. I did have three different equations because I had system high, system top, and system bottom. The only thing that's changing is this number, which is slightly different for the three. So bottom has the highest temperature, top is just slightly colder, and the high system is even slightly colder. Where did I get these numbers from? Because I went back to this prediction equation. High is 1.6 colder, and top is 0.77 colder. I don't know what a top system or a high system or a bottom system is because I'm not a meteorologist, but let's pretend that they all know what that means. As the altitude increases, temperature climbs 0.1056. This is just linear. Temperature is linear, altitude is linear, and so I'm just describing this slope, which I had to do like over and over. And I was trying not to make this boring by having the exact same wording. But how many ways are there to say as x increases, y goes up? As the polar vortex increases, temperature goes up by 20.93. What is a polar vortex? We don't know. We made it up. And don't just give sentences that describe the effect of the variables. Actually try to think about what it means. This means I want a bottom system, high altitude, high ground level, high radiation. So I was trying to think about this, and so I pictured a nuclear energy station on a mountaintop. So there's where it's warm, and yeah, that makes so much sense. The truth of this is what happens when you make up data and you're not real careful about what kinds of betas you put into the system. Now, wind speed was logged. So I said if wind speed increases by 5%, that's different than just increases or goes up by 1, right? 5%, remember that number, 1.04 that I told you to memorize? So that's how much it goes up. So this means that we want it to be a really windy day on the nuclear station, because reasons. Clouds, I can explain this. Okay, in this range it's dropping, here's my low point, and then in this range it goes up. So what do I want for clouds? I either want no clouds or a lot of clouds, and really a lot of clouds would be better because it will hide our nuclear station. Snow melt. There's a huge drop in temperature for small amounts of snow, but then after that the drop levels off. So we want no snow on our nuclear power plant because snow makes it blow up or something. I don't know. I'm really having trouble finding logical reasons for these variables when they don't actually make sense. Here is temperature. It goes up in this range, it goes down in this range, and then it goes back up. Because it makes so much sense that funding is going to affect the weather. I swear I actually gave this thought at one point when I was making the data, but then I got confused of the betas, and I think maybe I mixed up what betas were supposed to go with what variables, but this is what the data says. So whether it makes sense or whether it was a stupid data set, I can go through it, I can explain it. This is a fairly complicated data set. So let's try this again, and we're going to go through humidity, which is even tougher to explain.